Okay, hi, I'm Brian Kardell. I'm a developer advocate at Igalia.
And I'm Eric Meyer, also a developer advocate at Igalia. And welcome to this week's Igalia Chats. We have with us a special guest. Andy, please introduce yourself and let us know a little bit about what you do.
Oh, hi. Well, my name is Andy Wingo, and I am a compiler engineer. I'm just into programming languages. I work for Igalia for the last 15 years or so. And I'm excited to talk about Wasm today, or Wasm, whichever one y'all are up
Is
for.
it so the WebAssembly, WASM, and
So,
yeah, it's
yeah,
it's it's WASM?
I say Wasm, I guess. It's not an acronym, it's just a shortened version of the name. And hence, if you capitalize it, we know you're not a real one. So it's
Ooh.
capital W, but all the other ones are lowercase.
Oh, okay.
That's
Dropping
interesting. That's
dropping the
like,
knowledge in the beginning. Yeah.
Can I make a guess that the WASM is supposed to look like an assembly instruction? Is that
Oh, I've never thought about that before.
okay?
But I think it is supposed to remind you of assembly. Yes.
Hmm. Okay. So for listeners who may have heard about WebAssembly but don't really know what it is, like what's the deal? What is WebAssembly?
I would take maybe a historical. I mean, there are a number of ways to come at this, but one of them is to come at it from time,
Yeah, well,
right?
we love history on this podcast, so go for it.
we love it. Yeah.
So about 10 years ago or so, a little bit more than 10 years ago even, people were trying to squeak out the best in performance in JavaScript. And if you remember, like that was on the tail end of some of the real performance wars of, when V8 came out in, what was that, 2007 or 8 or something. And then web as the compiler architecture started to get more and more optimized, you start to look more towards getting kind of native level performance out of JavaScript, and people were running against a bit of a wall for some applications. JavaScript wasn't very predictable. It can go extraordinarily fast, but if you just give it a lot of code, it's a bit of a crapshoot as to what actually ends up going fast. And it's not it doesn't give predictable performance. And so people were looking to find some predictable performance out of JavaScript. And so people made a reduced a subset of JavaScript that could be statically typed and that was amenable to being emitted from LVM, essentially, which is a weird thing to do to JavaScript. People probably remember this. It's called asm.js, asm.js, and it
This
was
came
using
from
WebAssembly.
Mozilla Labs, right?
Exactly. Um, like so many good things.
Yeah, right. I mean, really, there were really a lot of great things that came out of that.
And then I think as people who work on compilers and language runtimes, like this was a very neat hack, ASM.js. You could one of the common demos back then was Brendan Eich would go around at all the conferences showing off Unreal-based games
Mm-hmm.
compiled to ASM.js, and there would be sort of these 3D shoot 'em ups all running on the CPU, but using web GPU from the DOM. So already from the very beginning, like the idea of compiling things from C++ to the web and then using the web platform was a pretty important use case.
If I remember correctly, wasn't ASM like actually just JavaScript, but it had sort of like comment oriented annotations in it? If your compiler understood ASM, it could do, fast things with it? Or is that a complete misremembering of what
No,
it was?
that is an accurate memory. It For Firefox, it would shift Firefox into a mode where it would eagerly compile the function that contains the use asm declaration at the top, which was just a string, a literal string at the very beginning, kind of like use strict or Google's attempt at use strong, and like a number of these proposals. But the semantics of what was compiled is exactly JavaScript. So it really was JavaScript, but just a subset that could be compiled well.
But was there like type hints on it too, or something like that?
No. Now there were inline patterns of JavaScript use which exactly constrain the values to have the semantics of low-level instructions. So, for example, if you'd or a value is 0, then that says it's an int32.
Right, that's what I was thinking of. Yeah, I remember Dave Herman showing me some of this stuff. I thought was interesting.
Like prefixing things with plus to make it a
Yeah, yeah.
number, often floating point. Yeah. Neat hacks. Disgusting. to
the
anyone
best
who
kind
has
of
a sense of
hack.
aesthetics.
Yeah.
And we programming language people, like, we have a sense of aesthetics, whether it's good or not. I don't know, but it's very strong, and this is not a common aesthetic which is appreciated in this community. so, so that's actually, I think, why WebAssembly arose. I mean, it was the implementers of the various JavaScript engines saying, this is a really weird way to get what you want. Why don't we design something that does exactly what ASM.js does, but more fit for purpose and maybe reusable in other contexts? That was 10 years ago. There have been a number of extensions since then, and recently some more interesting qualitative changes in WebAssembly and in its use domains. One context for this talk is ACMQ, the publication from industry-focused publication from the ACM, just published an issue on WebAssembly with a few different authors, myself among them, and my article took a look back. If you just go to q.acm.org, you'll find these ones right now.
Is that queue.acm.org?
Yes, right.
Okay.
I mean, try them all. Q
Well,
and then UE. I mean,
You.
we'll
Yeah.
link the article. You're talking about WebAssembly, yes, but for what, right?
Yeah.
That was a great post, actually. Like,
Hey,
I
thanks.
think that there are probably a lot of people who, write JavaScript and they know something about Wasm and they were like, kind of intimidated to dig into it or whatever, but it's like very, very accessible. And I think the title even is great because I think a lot of people have exactly that question. Like, sure, yeah, like we like it, but for what? Like, is it actually being used? Is it making a difference? And you answer a lot of those questions.
Yeah, it's a funny question because I mean I love WebAssembly, like many programming language people. I feel there a strong affinity towards it. But the web part has mixed success. I would
How
say.
so?
Well, in the sense that, like, you go to WordPress or Reddit or CNN or whatever page you go to on the internet, and I don't think there's any WebAssembly. Like it's not replacing anything on the web to a first and very large approximation. So it's like, what are we doing, guys? Is it actually a thing on the web? And it is to an extent. In the article, I take a look at like where things have succeeded, where things have failed a bit on the web, and it's mixed, I would say, in a web context. We have things like SQLite, for example. There was WebSQL. Probably you all have worked with this at some point.
Yeah.
And my understanding is this is just completely gone from. This is offered SQL to SQL to JavaScript developers in the browser, and this is no longer a thing. It used to be shipped as part of Chrome, for example, and now what people do is they just ship SQLite, SQLite, compiled to WebAssembly, and it's faster and it works great. So in some areas it's finding some success, but it seems to be limited to some of these add-on components, which themselves are compiled from languages like C and Rust. But people who are writing JavaScript right now are not also writing WebAssembly.
Okay. Yeah. So you say languages that are targeting WebAssembly. Rust, I assume, from a thing that you just said, but others?
Yeah, there are a number. The thing is that the first version of WebAssembly, it's what it gives you is the ability for it's a compiler target. First of all, it's not something that's designed to be written by yourself. You should be writing in a source language, and that source language's toolchain should produce WebAssembly.
Okay.
And the facilities that WebAssembly has are instructions that operate on a byte array, right? And this is kind of Turing tape level stuff. And notably, you can provide functions. This code that you generate is broken up into functions, and those can be exported to JavaScript if you're in a web environment. And you can import functions from JavaScript, for example, DOM functions, into the WebAssembly environment. And that's one of the interesting things about WebAssembly is that it doesn't have anything that it can do on its own. You have to provide all of these capabilities to it in the form of imports, which is also a very attractive property as a programming language person. But the way that the set of primitives that it has, meaning this byte array and imports from the host, means that it's really appropriate to languages that are already, whose tool chains already target byte arrays, meaning C, C++, Rust, and that's about it. Right? Go to an extent. I mean, Go has a garbage collector.
I think that's an important distinction. If you could like go into that a little bit, because I don't know that everybody is sort of a language engine nerd. So what does having a garbage collector have to do with?
Right.
Yeah, let me give that a go. So in a programming language, you have control flow and you have values, and in some languages, those values, for example, a JavaScript object in the context of JavaScript, when you create it, you don't know how long it's going to be around. There's nothing that guarantees that it's going to not outlive the current function call. There's nothing that guarantees that it will only be used by one caller at a time. When you mutate a value on it, there's no guarantee that somebody else doesn't have a value. Values exist in this kind of soup. And it's not clear when it is that a given value is not needed anymore. To determine that, you have to trace all of the links between all the data structures in your whole program, and then any object which is not traversed on that trace then becomes reclaimable. That's garbage collection, right? But that's not the only way that you can build a language. You can build a language such that by default, the values you create, a struct containing, I don't know, a string and a name and a handle on some sort of resource, it has a sort of statically delimited lifetime. So you create it in this function call, and there's something about the programming language that proves that that value will be unneeded after the function call is finished. And in a language like that, like Rust, for example, even like C and C++, when they're used conventionally, you can use a different strategy for representing values. You can, for example, use a stack, in that as your control flow goes deeper into a function, you can allocate values in linear memory, and then when the control flow returns, you just have to reset the stack pointer, and everything is freed and available for the next call. You don't have to do garbage collection. So WebAssembly with its linear memory was appropriate for languages like C and C++ and Rust, but for a language that needed garbage collection, that needed the engine to determine when a value is live or not, like JavaScript itself, WebAssembly was missing this facility, which it just got last year before actually. And I mean, as programming language nerds, we're super excited about this. And so it's almost like a new chapter of like what's going to happen with WebAssembly. Like our languages like C# and Dart / Flutter. I wrote a scheme compiler also to WebAssembly with GC, garbage collection, last year. Like, are these languages going to have success now that they're possible?
What does it take to write a compiler like that? I'm just curious.
It's for me, the challenge of targeting the web is binary size, right? Like you can do many things, but if you want to make a good user experience, you need for that delivered artifact to be, less than a megabyte and hopefully, less, right? You need to be able to produce tiny binaries. And for that, you need a compiler that has that's able to do a lot of tree shaking in the same way that JavaScript, the tool chains, their bundlers can remove excess code. You need a compiler that's really oriented towards not including things that you don't need. Types help to an extent. If you can prove that this addition is not going to see strings, for example. If your addition operator can work on strings, then you can emit less code. You can make things smaller. But also the structure of your language's standard library is such that the toolchain can know when something is not in use and can produce a small binary. And I have found in my work that you need to spend some special effort on the web to get this. There's a faster strategy, which is like you take the canonical Python implementation, for example, which is written in C, and you just compile that C implementation of Python to WebAssembly using the standard C to WebAssembly toolchains, and then you use that to interpret Python inside. It's compiling an interpreter instead of compiling a program directly. The result is a bigger binary that runs slower, but it does give you Python on the web, and I think that's valuable, but it's not going to replace JavaScript.
Right. So you're in that case, you basically people are creating the ability to run Python natively, maybe air quotes, are the air quotes appropriate here, in the browser, so that rather than writing JavaScript that's equivalent to whatever Python you want, if you know Python much better and you have this Python Wasm thing, then you can just run that and then throw Python at the browser and the Wasm does stuff with it.
That's right. And there are some ways you can improve on that. This is going to go a bit nerdy, but if you take an interpreter and you specialize it against a program to be interpreted, then that produces that is a compiler, right? So if you take a Python interpreter and you specialize it against a particular Python program, then you can get an optimized WebAssembly program for that Python program. There are limits, but people do this. There's interesting work called Weval, W-E-V-A-L, out from Chris Fallon a year and a half ago or so. There's a lot of interesting work on this. You can also get an implementation of an interpreter to produce WebAssembly code just in time. And me and my colleague Dmitry Bezhetskov did this for SpiderMonkey about a year ago or so. So instead of emitting like x86 or ARM code, we would get SpiderMonkey's macro assembler backend to emit WebAssembly, which would then be linked into the process, and you would have somewhat optimized JavaScript on top of JavaScript. Because you had the SpiderMonkey implementation compiled to WebAssembly, which could then run on top of SpiderMonkey itself.
Wow. We do a lot with ones and zeros, don't we?
So I live in Pittsburgh, and a number of years ago, we used to run this event here, and it was, to explain web standards and to like engage developers. And there are a few like web oriented people in Pittsburgh. So like Brad Frost is here, Val Head is here, I'm here. And at least at the time, Lynn Clark was here, and Lynn Clark was working on this. If you remember Lynn Clark, I don't know. I haven't seen her in a while. She did the web comics for this. We'll link them up. I don't know. Are they still accurate? I assume that they are. But that's probably the last time I got very into something about Wasm. And there's a question that is persistent in my head that I would like to see if maybe you can help me understand and answer from that era, which is basically, it's a bit like it's something that runs in a worker in that you can't have access to any of the stuff that makes browser stuff happen. Like you don't get access to the DOM. You can't access like, local storage or IndexedDB or can you do those things now?
The answer is nuanced. So on the basic level, you could always access DOM functionality by importing functions from the DOM. you don't have them directly, but when you call out to your host, when WebAssembly calls out to one of these imported functions, then the host can access IndexedDB. And so when you write your WebAssembly program in Rust or whatever, you would import IndexedDB bindings, and then when you instantiate that module on the client side, you would provide it links to the IndexedDB functionality. So it could link out there. That said,
How does it do that in practice? Is that like a user land thing? It's not. Is a thing provided by the browsers or?
the low-level mechanism is pretty simple, actually. So in a WebAssembly module will have some set of imports. This is static. It's an attribute of the module. Let's say it has 20 imports. Each of those imports can be a function, or it can be value, or it can be, there are a couple of other internal things, but mostly you want functions, right? So each of those functions has a type. And the module itself declares this import number 19. I'm going to import it from a module called env, is a common name that is just the compiler tool chains produce. And then inside that module, I'm going to import the function IndexedDB new. There's no semantics associated with this, right? And this function has a type. It has 2 arguments. It's going to return this value. There's no semantics associated with the import in and of itself, but the tool chains, when they produce WebAssembly, Emscripten, it will also produce a bit of JavaScript on the side that wraps that module. And you use that JavaScript to instantiate the module. And when you call that JavaScript is going to fetch the IndexedDB functions and the WebGL functions and all the ones that your module needs and pass it as imports 1, 2, 3, 4, 5, and 6.
Oh, interesting.
Into your module. And so inside the module, it needs something from WebGL. I know that my WebGL function is slot 6 on my imports. I'm going to call this function with the right number of arguments. Control will be passed directly to JavaScript. It's a very low-cost boundary. The engineering there on the part of the browser makers is very good. So if you're calling out to DOM facilities from WebAssembly, the actual fact of calling out is cheap and is often inlined. So
Nice.
there's a line running through your program between the WebAssembly side and the JavaScript side, but the runtime makes it as cheap as possible. And that's a general characteristic of WebAssembly, is that it's good at making lines through systems and lines through programs where one side is one thing and the other is the other, but the cost from going from one side to the other is relatively low. Okay, all that said, I have to provide a little more detail though, because values going across this boundary that aren't just integers, because WebAssembly's fundamental data types are integers, floating point numbers. That's it, right? So you have a string. What do? It's horrible. The WebAssembly module, when it wants a string, has to pass an offset into the linear array of bytes. And then the imported function on the JavaScript side has to write those bytes into that typed array, corresponding to the value of the string. You don't get to pass this string by reference. You copy its value out, and then to get the value back into JavaScript land or whatever the host language is, you have to copy the string back out from the bytes to the array. And that's the case for any composite value. If you have just like an opaque resource, like an IndexedDB database or something, those can remain opaque and they don't have to be copied. They effectively sit in a side table and they have a reference count associated with them. But for anything is more complicated, getting data in and out of WebAssembly is a bunch of copying. Until this facility recently to allow WebAssembly to make values whose lifetime is managed automatically by the garbage collector. That allows JavaScript values to flow into WebAssembly to be stored in local variables, passed as function parameters, and exist in WebAssembly without being copied out. Now things aren't as nice and fluid as they could be because the standards body wants WebAssembly to be appropriate, not just for the browser. If it were made just for the browser, I think things would be more tightly coupled between WebAssembly and JavaScript, but that's not how it is. But the GC facility gives the possibility of having less value copying and making that line a bit lower cost.
I don't know. I feel a little lost sometimes. It's like there's all these things that are talking to each other, I guess, and like how does it even all work? But I guess that's once you get like down into the weeds and make sure all the weeds are lined up correctly, then you get what you want. But you mentioned about the standards body. What standards body is working on this?
So it's a W3C, to cut it short.
Okay.
That's strange a little bit to me. Like I would have thought it would be ECMA, but it winds up being W3C.
I can't say why. I actually don't know why that is. In practice, I think it was maybe related to royalty-free membership.
Okay.
But that's worth diving into a little bit more. In practice, there is a working group which formally ratifies standards, and there is a community group that does all of the work. And the community group is relatively open. It's a kind of rough consensus-based model with phases as in JavaScript land. And once you reach phase 4, then you are blessed and incorporated into the standard. It's a multi-stakeholder process, and there are two sociological sub-communities there. There's the browser manufacturers, people who are focused on WebAssembly in the browser, and then there are the people who are focused on WebAssembly elsewhere, which is largely these days a server-side thing.
Yeah, I like in your article about this. I'm pleased you're going to talk about this because some of that was fascinating to me.
In the browser, I think we can measure a bit of WebAssembly success, and it's been around long enough. It's filled a space, but it's not growing and stampeding over everything. But on the server side, I think we can't quite do that yet because people haven't been running it on the server side long enough. But it's still expanding and it's interesting. So there, the idea is there's a system user split on the cloud. You have the cloud operators that run the system, and then you have everybody like us who upload our programs to a virtual machine or what have you, and we are the users, right? And there needs to be a dividing line in between those. And a long time ago, obviously we had managed machines, and we went to virtual machines and containers, and now function as a service. And WebAssembly is another step in this line of making the unit of computation smaller and cheaper, and increasing tenancy on these servers by having very small instances.
Just in case people don't know, tenancy is like
it's that multiple people share physical resources, and obviously, right, if you are running a cloud infrastructure, the more the merrier. For your bottom line.
Just offering that as we're throwing around a lot of terminology in this episode, and I feel like the more we throw out without getting some kind of definition, the more lost people will feel. So just in case.
For robustness, it would be nice if you could completely spin up a fresh virtual machine, for example, for every web connection you make to google.com. Right? You spin up your virtual machine, you get your search results, and that virtual machine gets torn down. It doesn't work that way because it's too expensive to start a virtual machine, both in the amount of memory it ultimately consumes, but also in the time it takes to do so. Like you have a couple of milliseconds in which to do this. And in especially edge deployments, let's say you have like so this is like not in a main data center, for example, but like Cloudflare, Fastly, or one of these services, Akamai, that have data centers all around the world, very close to where people are. Let's say you have a Black Friday sale or something, to take a capitalist example, and you have a lot of a load transient, like a lot of interest in something. Then you're going to be starting up a lot of instances everywhere. But this could actually lead to overloading the entire system, as the latency of each little virtual machine effectively starting up everybody's doing the same thing. And so everybody's waiting the 100 milliseconds. All of your queues completely fill up and the whole system falls down. With WebAssembly, you can start a virtual machine. I put this in air quotes here. In between 100 microseconds or 2 milliseconds or something very small. So the idea is that you can scale up and scale down very quickly, that these are very simple units of computation. And the low-cost line between the kernel space and user space, again in quotes, that is established by WebAssembly allows it to produce systems that scale horizontally a bit better. So on the server side space, there is a kind of, like, everybody's heard of Kubernetes, right? Whether or not it's positively or negatively, it's just out there and everywhere, right? And we're still in the kind of growing a Kubernetes moment for WebAssembly. There are a number of companies that have offerings out there in this space of providing scalable virtualization based on WebAssembly units of compute. There's still space to go, I think, to fill the niche. So there's still a bit of runway in this area.
Yeah, that's amazing to me when I read that you're measuring startup time in like microseconds. Is you can imagine that being a really big deal for edge computing, especially. Yeah, it makes sense. I had a question about usage and like getting at some of the like what is being adopted, why isn't being adopted. I mean, I really thought that maybe like the access to DOM and things like that would be one reason, but it turns out that that's not a reason. I wonder if people just don't know that. One of the things that we've seen with standards a lot. So Eric and I both have done stuff with the HP archive and the Web Almanac just about every year. We study a lot what people are adopting, what they're not adopting. We do these surveys with the WebDX group, and we do this interop project where people ask for things, and then we also help boost lots of other developer advocates saying, hey, what can we give for you? And it turns out that a lot of people want things that turns out we already have. They just don't know it yet. And when you look at the adoption curve for a lot of things, not everything, but a lot of things, it really takes a long time for you to see it in the data. Unless, for example, like Wix or WordPress or one of these like core systems that's used by, maybe a quarter of the internet or something like that were to adopt it, then you see it ripple through. And then the interesting thing there is how to interpret that, because it's not that people individually made choices to choose Wasm. It's that Wasm was chosen by the invisible hand of, capitalism. They bought a product and that product used it. And that might be the good part, or it might be the bad part of the project. But, we just don't really know. So, but when we look at that data has like a lot of like biases. And I'm curious, like you said, we know on the web, how are you getting that data about that we know about adoption on the web? Is it from HP archive and Chrome status and stuff, or
I don't have a good, my data is anecdata. I don't have data in this regard. Yeah.
Oh, okay. This would be interesting to look at on, if you're interested. I would be interested in looking, but I expect that it would be low because the biases of the HP archive are toward homepages, and even on the Chrome status, it's sometimes difficult to get things where you're behind a login or a firewall or something, and so I expect that a lot of things that you might use that for, like gaming, I think that's actually one of the reasons that it took off in the first place. You can correct me if I'm wrong, but I think that there was like people saying like we need this for gaming, and some of the first uses were like Unity and stuff.
Well, a couple thoughts on that. I think for gaming, it was a really interesting technology demo. It surprised a lot of people 12, 14 years ago when there were those demos using an Unreal Engine. And but it hasn't worked out. I suspect it's not simply a technological issue. I think it's more economics of AAA game production. How do you ship them? And maybe Steam is better somehow. But Wasm has not been a big success in games. Some people do games in Wasm. I'm not saying, and they're great and I love them.
I actually did.
Yeah.
Strangely enough.
It's
the only Wasm that I think I have ever produced.
Oh, wonderful.
A couple years ago, I was messing around with Godot, the game development engine, and I made a lunar lander clone, right? Because it's like a simple project to do. And it had like compile for web. And I was like, okay. And it produced like 20 megabytes of Wasm, which then ran in the browser, and I could play Lunar Lander, my terrible copy of it in the browser. But yeah, I mean, given that AAA games that are not in Wasm are like 500 megabytes or sometimes gigabytes, depending on what they're doing, I can't imagine that Wasm is going to make that somehow smaller.
Yeah. I'm happy to hear that your toolchain experience was good though with Godot.
I mean, Godot made it easy. Basically, it was whatever, and I don't remember the exact command, but it was basically publish because Godot has like publish for Mac, publish for Windows, publish for Linux, and then there was publish for web, whatever the phraseology is. So yeah, it spat out a big Wasm blob.
Well, Unreal, the current version, don't remember if I said this, it doesn't even include this publish to web thing anymore. So that's a data point. But I don't want to be negative on Wasm because I love it, right? Wasm has had some success besides games. Google Sheets is a pretty funny one, I think. The Google G Suite apps, the Docs and Sheets and all these things, like they're very large industrial artifacts. They're a single producer, even if multi-team inside artifacts. And one of the parts of Google Sheets used to be compiled from Java, of all languages, to JavaScript, and it is now compiled to WebAssembly using the new garbage collection integration. So the ability to pass values by reference back and forth between the different parts. And that, I think, has been deemed a success. I think to really evaluate it, we would need to look at it in another 3 years and see if it stuck. But it rolled out and deployed.
Yeah.
Doesn't Adobe have a bunch of Wasm stuff too?
Also, and that is another case of a legacy application compiled to the web. And so they effectively compiled Photoshop, for example, to the web. Had to do a bunch of investments on the tool chain, but they got it working. I understand that it's really not a web port of Photoshop, and even if it integrates with web facilities, like it really is the Photoshop application compiled for the web target. Whereas if you were going to make Photoshop from the web from scratch, as if making Photoshop from scratch is a thing, you would make it in a completely different way. Like the only reason it's targeting WebAssembly is because there is this large legacy code base written in C++. So if you have one of these things that you need to get on the web, then WebAssembly is an absolute win. There's just a limited number of such things. When I think about the web and WebAssembly, there is this narrative that we have publicly among WebAssembly partisans, which is that WebAssembly is a complement to the web. Whereas, and that's true to an extent with like SQLite, for example. Whereas I think in our hearts of hearts that WebAssembly is in competition with JavaScript. Like somebody who loves WebAssembly does not want to write their web page in JavaScript. And I think it shows in the sense that somebody who loves JavaScript is not going to go and write a little part of their web page in WebAssembly. That to an extent there is a desire to replace the messiness of the web platform as it is with something clean room like WebAssembly, and I think it's an aesthetic exercise that falls flat.
This is kind of a perfect segue to a question that I've wanted to ask for a while too, which is I think when you take a really large JavaScript application and you send it down, one of the larger things is parsing, right? Because you parse it and it builds a kind of internal bytecode and stuff, right? Because it's a virtual machine. And a really long time ago, I was like Java developer, but it had bytecode, and you would send this. It's not text that you interpret. It's this kind of in between thing. And a lot of people proposed for a long time, like, hey, why don't we just have like where you can compile your JavaScript to bytecode and you send your bytecode down? Seems a little bit to me like that's what Wasm is. And I'm wondering, like, do you gain performance boosts from it? And also, like, has anybody, like, I literally don't know the answer to this question. Has anybody like worked the tool chain so that it could sort of work that way? I expect probably not, since some of the things you were saying are new, but like,
Yeah.
and I would like to, like I was able to with Java, not debug bytecode, but debug my JavaScript
Well, I
code.
think it makes sense to deliver WebAssembly and write TypeScript, right? But the full
Okay.
dynamicity of JavaScript is best served by the JavaScript implementations as they are. So first of all, on the parsing side, text and bytecode are similar in size, and parsing the text is not actually a blocker. The JavaScript parsers in the implementations are very fast, and they can operate off main thread, and they can scan for function boundaries, so they don't actually have to build up an AST, maybe even initially at all. It's been a year since I've gone deep into the JS side of things, but the like a bytecode for JS was never a win from a startup perspective. WebAssembly does have some facilities that can lead to low latency, but it's also very low level. And that means that to get a given task done in WebAssembly will require more instructions than JavaScript. It would be nice to be able to have a good compiler from JavaScript to WebAssembly. The current ones are, a lot of people use QuickJS, which is an interpreter. Some people use SpiderMonkey, which is also run in interpretation mode with some specialization. The binaries are still a little bit large, I find. There's not a really good compiler for TypeScript yet to JavaScript or to WebAssembly with GC that I know of, but that is actually an open space. The other question is, like, do you want to do this to your system, right? So WebAssembly, what it does is it draws a line down your program where you have the two sides, your host and your guest, right? Often these correspond to something approaching kernel space and user space. And it's great when you need that line, right? Like on your cloud provider, you provide the OS, the user provides the function that runs in the OS. You're a browser vendor, you provide the browser implementation, the user provides the JavaScript that goes on top. If you provide a website, you don't need a line down the middle of it, right? So if you divide your website into JavaScript and WebAssembly parts, you're going to have to divide your team into a JavaScript team and a WebAssembly team. And this technical boundary, like it's a reverse Conway's law sort of thing, is going to put a lot of organizational friction such that the cost to communicate across this boundary is going to replicate itself in the number of people they're going to have to deal with these problems. And it's not, for me, the winning deployments are either all WebAssembly, like Flutter, for example, Flutter compiled to Wasm GC, or all JavaScript. And I don't, or JavaScript with one of these very reusable modules like SQLite or something like that. Looking at a web deployment scenario, I don't see a good plan for like implementing Facebook in WebAssembly, for example. It just doesn't make sense.
Yeah. So in that framing, it's hard to imagine, you know, it overtaking JavaScript or really catching up to JavaScript, because a lot of things that you need to do are webby by nature. Flutter also has like additional interesting challenges and things because I think it doesn't really provide you with the same native things. Which is like games, they like it, right? Like they want to recreate all their own controls and everything. But then that is that's tricky. I mean, that's why we have things like Qt, and it's why we have toolkits, because like it's really difficult to build a good UI that is accessible and all that kind of stuff
But
as
maybe they
well.
could with more investment. I could see it maybe being a thing. But
Sure,
yeah,
sure,
I
yeah.
agree. It's a tricky proposition.
I think the things that attract it is maybe the problem. Like the things that attract it, like Flutter and things like that, that want, like they genuinely want to build their own stuff. So it's a little bit hostile to
Yes,
building the common thing. Not hostile. It's not conducive to
I think that's
encouraging the
right.
common
Yeah.
thing, I guess. Yeah. It's a fascinating topic. I also am interested a little bit about you mentioned like SQLite. So does this mean that you're sending down a database engine when you want to use that one component? I mean, it's a small database engine, but you're sending down a database engine. And I guess probably that must back with something, right? Like it must back with something local, like it's using IndexedDB
I
behind
can't
the scenes or
remember.
something.
No,
Like,
I don't remember the details for how it keeps its local state. But yes, it does seem silly to send a database from the server to the client.
yeah, and I mean, well, this is a common tension that I'm a little bit curious actually for you, because you do like some of these things, and you probably have more insight into some of them than me. But from my engineering career, it's always been this tension between like you can build a nice app with Electron, and then exactly what you're sending, right? Um, but it means that you don't get like the free security updates that come with the browser. It means that we have 380 copies of Chrome on our desktop. You know, like every app is their own copy of Chrome, and each one maybe has their own security problems. And
But
I don't know. It's a tricky balance.
to be fair, JavaScript is like that, right?
I was going to draw an analogy to like there are a billion copies of jQuery on my in my cache, right? Um, like it just didn't make any sense when we were really fighting for every bit of cache storage that we could get on these really finite devices. And I know there were a lot of efforts, still are, to how we can avoid that. Like, is there a privacy secure way to do that? And even the things that we had, like loading them off a CDN so that they shared a cache, they don't anymore, because they like multi-hash the caches.
Well, let me take this in a slightly different direction, which is in off the browser and more towards the page that you receive. Like when you go to Amazon, for example, you can't cache that result because there's your name up there in the corner, and there's like your recommendations here or there. The page which gets shipped to you over the wire is not really compatible with the HTTP 1.1 caching architecture, right? And it's all over HTTPS and everything else. But a lot of the page is the same. You have a number of blocks that aren't going to change every minute. At least you can cache that. So that's one thing that WebAssembly is being used for now, is taking parts of a page like Amazon.com. I understand that was one of the ones recently, and stitching them together on the edge with customer-specific information. So you take a block of this and a block of that and a block of that and some customer information, do some logic, and produce the HTML and JavaScript that's shipped over the pipeline to the user. And in that way, you minimize the total latency of the operation because the data center connections are very good. And you also allow those core servers that produce the page to focus on what they're doing and then scale the part that's very dumb. It's just the stitching together the parts of a page. So maybe to an extent, I know it's only tangentially related to like the having 17,000 copies of jQuery around. It's a form of prayer or something. that WebAssembly allows us to like decrease the total number of bytes being sent from core data centers and allows things to scale in a cheaper way. It's not a counter argument. but maybe more intelligent caching can be made of data plus a bit of logic, and WebAssembly could be a cheap form of logic.
Yeah, there have been a lot of approaches to this. Mark Nottingham, when he was with, I believe, Akamai, and he's Mark Nottingham, if you don't know, was the chair of the HTTP working group. He had a proposal that I can't think of the name of it, but it kind of never took off. But it was like a standard way to do this at the edge, that you could stitch things together. I still think that's a pretty good idea. I also built something like that at my last employer, and it's a very good idea. I don't know if you have followed our last chat.
I read the transcript, but I wouldn't be able to listen to it. Yeah.
A number of people have suggested, like, hey, can we just like transpile XSLT? Like, there are modern XSLT engines. Can we just transpile them? And I'm curious, like, is there anything preventing us from doing that?
You can do many things. And I know you're wondering, like there's when you load an XML document, you kind of have a DOM representation, and it would make sense to be able to just move around parts from that DOM implementation using XSLT. I think with WebAssembly, it really wouldn't work like that, unless the particular XSLT implementation is designed for the XML being stored in a kind of DOM, in a third-party resource that you manipulate by handle. I think the way it would probably work would be more textual. XML in, XML out.
Right.
Or whatever out on the back end.
But as a string, so like HTML out, for example. Yeah. So you kind of like multiple parses happening there. Less efficient at runtime, probably.
It probably doesn't matter, though, for all the use cases that people are looking at it for. And I don't know. I don't know why people would do that instead of using a different programming language, because XSLT 1.0 is not a great programming language.
Yeah, but they want to compile a more recent, like XSLT 3, but that means also like updating it, again, the dependencies and everything. So XSLT requires XPath. The browser's XPath engine is also not up to snuff, so you need to compile that as a modern one. And then like, it also works on JSON. You can't, like, you have to figure out how to take the JavaScript engine's JSON parser as a reference, or again, it's string in, string out. So it just feels doable, but more as I don't know. Maybe it's kind of a beautiful Rube Goldberg machine.
Sticking on the WebAssembly side and without my programming language hat on, yes, it's totally possible. It would, and there is an interesting thing. WebAssembly is a boundary. It doesn't have to be implemented by interpretation or compilation. One of the ways that you can use WebAssembly, which is the way that Firefox does, I can't remember which library I think it's actually libxml that they do something called RLBox, which takes the libxml source code, which is written in C and surely has security, like memory vulnerabilities, for example. They use a standard tool chain to compile it to WebAssembly, and then compile that WebAssembly back to C. And what you get is an artifact that has no undefined behavior, and which by construction cannot alias memory from the rest of Firefox, and cannot invalidate any of the invariants in its host, which is Firefox, besides what Firefox provides to it in the form of import functions. So it provides a useful security boundary inside Firefox between two pieces of C code, ultimately. And in this case, this is C code, which is produced from compilation from WebAssembly to C. So in a place where you need a boundary, WebAssembly, I think, is a very, very interesting technology to take a look at. I was talking with a colleague just yesterday. He was saying, I would like to have some mobile code. There are all these coprocessors and embedded devices that run Zephyr these days. And sometimes these coprocessors are just, doing nothing, but they're taking power. Maybe they're plugged in. They don't need to save battery. How do I get mobile code? And I'm like, WebAssembly. WebAssembly is the way to do this. it provides you this cheap boundary between the trusted runner of programs and the untrusted program that does interesting things. So I think it's a good general strategy. For a browser, obviously this would mean shipping more code and more facilities to ship libxslt as either compiled back to C or interpreted or what have you. That's a decision from a browser maker to if that's worth it or not. And I am very sympathetic to the desire to remove things. So,
is there anything that we didn't cover about Wasm that we should cover that you would like to cover?
I think my big pitch with Wasm is that is this drawing a line in your program, and that it's a pattern that we can recognize in a number of deployments on the web to a degree, like where you have a line between SQLite and the rest of your JavaScript application. On the cloud, where you have the cloud provider and then the function that is being run on the cloud. But wherever you find this kind of line is an interesting potential development niche for WebAssembly. So I think people should be writing kernel drivers in WebAssembly. This is not quite a thing yet, but it could be. Operating systems can be built using WebAssembly as the boundary. And this is kind of back to the Destroy All software. Gary, is that his name? Bernhardt? When ASM.js was a huge thing, he gave a talk which is a history of computing and then ended up with ASM.js, like JavaScript being the future of computing because it will be the boundary between kernel space and user space using ASM.js as the abstraction layer between them. Anywhere you find this line, it's a potential deployment area. And in the article, I had a fun time. I predicted that in AI context, where you have agents doing things, doing logic on your behalf on your data, this is another line. And then a month later, Microsoft comes out with Wasm agents operating on your data within a security sandbox. So I think we have room in a non-web context, and then on the web, I'm interested in looking towards the future of this new GC facility, the garbage collection facility. Let's see where it goes.
All right. Well, this has all been really interesting. And especially for me, who has been afraid of assembly ever since I failed the course in college. And my failing really was that we had lab partners, and I was partnered with the one student in the class who probably should have been teaching it. So they just turned in their assignments the day that they were issued, and went off to do other things. Anyway, Andy, thank you so much for joining us and giving us some enlightenment on Wasm.
It was a real pleasure. Thank you for having me on.
Thanks, Andy.